Hi everybody, my name is Travis Rainey, and today I'm going to be talking about Acris blanchardi, the Blanchard's cricket frog, and about part of my master's thesis assessing population structure at the range edge of the Blanchard's cricket frog. Acris blanchardi, the Blanchard's cricket frog, is a small, non-climbing member of the Hylidae family with an extensive range depicted here in the dark gray to the west of the range map. Previously, Acris blanchardi was one of the most abundant frogs throughout its range, but it's been well documented that northern populations have been declining for at least the last 40 or 50 years, which has prompted many states and a country, in the case of Canada, marked here with stars, to put Blanchard's cricket frog on their lists of species of greatest conservation need. And possibly exacerbating these declines are some notable ecological and biological characteristics. Firstly, they have limited dispersal ability and are relatively aquatic, staying near their breeding sites year-round. And in the decline zone in the north where they experience winter, there's a huge survival bottleneck overwintering. They are not freeze tolerant and they do not actively burrow. So most individuals will actually not survive their first winter, and there's almost no chance of an individual surviving 2 winters. So essentially, they have 1 breeding season to reproduce. Also, forests, development, and roadways are barriers to movement and could potentially leave remaining populations isolated. So I've been focusing on populations in Michigan's Lower Peninsula for my master's work, and I've mainly been focusing on characterizing the population structure of the extant sites in the state. So in other words, I'm trying to answer how many populations are there, how are subpopulations related, which I ultimately hope will help conservation efforts by prioritizing sites that might be isolated genetically or inferring connectivity concerns between sites. So we attempted to collect 20 samples from all extant sites, which were identified by call surveys I did in 2021 across all known georeferenced historic sites of the species. And then in 2022, we successfully collected 782 samples from 42 different sites covering almost all the known extant populations. So we didn't quite get 20 samples per site, but we got between 5 and 29 per site. And the smaller sample sizes of some sites were on account of the populations at those places being particularly small. So in other words, there might have not even been 20 frogs to catch and sample. So proportionally speaking, the genetic variation of all sites was adequately sampled. Then I genotyped individuals at microsatellite loci cloned from Blanchard's cricket frogs, which allowed me to get all kinds of lab experience that I had previously lacked. Today I'm presenting on data from 12 such markers, but I am in the process and almost finished with adding another 4. So eventually I'll have 16 loci for my final. After cleaning and binning allelic data quality measures were checked. So first, Hardy-Weinberg equilibrium was tested for in GenePop. Deviations were of no observable pattern. For example, no populations had more than 1 locus out of equilibrium. So deviations did not cause any populations or loci to be discounted. Similarly, linkage disequilibrium was also tested for in GenePop, and allelic variation was not found to be correlated between any loci. For missing data, we also checked to make sure that all loci had at least 80% of individuals sampled, which they all did, as you can see in the histogram. And we also removed any individuals who did not have 80% of their genotypic data scored, which caused 16 individuals to be removed. Also made sure no genotypes were identical, which could have happened by double sampling an individual, which is feasible given how small they are and how tiny their little toes are. And so we've also reran 609 PCR reactions so far. We're going to do more, but I've done 609 so far and blindly rescored the alleles. And so far, contradictions have only occurred 3.1% of the time. So the genotyping seems to be going well. Checking data quality, we then ran population genetics summary statistics. So for allelic richness, rarefying to 10 alleles to fit our smallest sample size of 5. The rarefied allelic richness per site varied from about 2.8 to about 7, with a mean of about 4 alleles. Again, rarefied to 10. Heterozygosity per site varied from 40% to 80%, with a mean heterozygosity of 63%. Inbreeding varied across sites, with some sites being more inbred than expected with random mixing. Other sites, fewer sites, but other sites actually did have, seem to be more outbred than would be expected at random. 7 sites here in red have inbreeding coefficients above 0.125, which for reference would be the relatedness of cousins. And we'll be looking at some of these specific sites in a little bit. Here's a matrix of pairwise FSTs, the genetic distance, calculated using the Weir and Cockerham method. There's generally a high pairwise genetic distance across Michigan in terms of speaking of pairwise, whereby higher FST means that there's less gene flow. According to thresholds from Wright, an FST above 0.15 indicates moderate differentiation. Above 0.25 indicates great differentiation. So essentially any warm color on this matrix suggests moderate to extreme differentiation. 29% of pairwise comparisons in this matrix are above 0.25. Now getting into population structure, we use the program structure, which is aptly named. We use the parameters shown. We will be increasing these parameters for final analyses and publication, but with the data set as large as ours and trying to get some results to present here in time, and how slow structure can be to run, this is what we used, but which is still actually pretty comparable to modern literature. Following Evanaux's delta K method, the K equals 24 scenario was the most likely, meaning there were 24 genetic clusters found. The K equals 24 scenario provides pretty clean site groupings, as you can see in this Q plot, where all but 3 sites are almost entirely comprised of just one genetic cluster. So applying the structure results back to the geographic context of these sites shows a high degree of population structuring across Michigan. However, we found some groupings of neighboring sites, and in one case, some not so neighboring sites, which we'll discuss. There are 10 clusters outlined in black here that group more than one sampling site. Conversely, there was also some differentiation between neighboring sites. So within the red outlines, you can see geographically close sites that are genetically dissimilar. So geographically close, but genetically distant. We wanted to see if pairwise FSTs corroborate the groupings identified by structure. So the mean pairwise genetic distance for the grouped populations was significantly lower than all other non-grouped pairwise FSTs, which generally speaking corroborates the clustering of these sites by structure. Now looking at individual groupings compared to non-groups, we see that most groups have a lower pairwise FST, meaning genetically more similar, which would be the expectation, than the non-group sites. But one group is equivalent to the mean pairwise FST for the non-grouped comparisons, which is this bluish-green cluster here. This is a group of 3 sites, and it oddly clusters this southern site, which is about 55 kilometers away from the other 2 sites. the other 2 sites happen to be along the Grand River. So maybe this group will be split up when we increase the parameters or increase the, add more data. Or maybe this is a real grouping, and maybe frogs are moving across this expanse at some frequency. We don't quite sure yet know. And staying on the topic of the Grand River, this yellow grouping here has an odd site included, number 27 here with a question mark on it. This site has one of the more ambiguous admixture proportions with a hodgepodge of clusters. As you can see at the top of the Q plot, there's like a rainbow of admixture. This site also had the highest inbreeding coefficient. So something weird seems to be going on here. There's still a lot of questions I have about this site and the other Grand River sites, which I'm looking forward to digging into more. One question, I had the hypothesis that since the species is known to inhabit and breed in all kinds of aquatic features, including big rivers like the Grand River here, that maybe there's some kind of passive long distance dispersal happening at the larval stage, whereby tadpoles, are catching rides on currents downstream. But the Grand River populations don't seem to be supporting this. However, structure did group these 2 sites, and prior to 2005, cricket frogs had not been found anywhere around here, and then the northern population was translocated. The southern site was not translocated, so it must be a colonization event, probably through the stream corridor there. So this stream dispersal question, along with the instances of geographically close sites that are genetically distant, so I'm also going to be applying landscape genetics analyses, like least cost path modeling, to see what other landscape factors, if any, besides geographic distance, account for the variation in pairwise genetic distances. So in summary, there's a high degree of structuring across Michigan, but with some evidence of localized admixture. And we argue that future species-specific management ought to consider these gene flow results and connectivity. And I'd also like to give special thanks to my wonderful technicians, Emily Trice and Keaton Clariday. And also thanks to all these funders and various forms of support. And